In this lecture, we are going to solve few problems using the same concepts that we have studied in the chapters like Kirchhoff's current law, Kirchhoff's voltage law, Ohm's law, series and parallel combination of resistors, and then delta to Y transformation. Let's start from the first problem. In this problem, you can see that we need to calculate V and Ix in the circuit. So that circuit is given with 12 volt independent source, 12 ohm resistor is connected, and there it is 2 volt, 8 volt, and then the dependent source 3Ix. And these are the unknown Ix, and we need to calculate V. First, we need to consider loop 1 for the solutions. Like the loop 1 consists of three components: voltage source, 12 ohm resistor, and then this component which has 2 volt. So if you apply current passing through this component in a clockwise direction, then you can use Kirchhoff voltage law in this loop. So according to the Kirchhoff voltage law, the current is entering into the negative direction, into the negative sign. So that is why here you have minus 12. So current entering into positive V, current entering into positive, so then positive V, positive 2 is equals to 0. And then you calculate sum and differentiate this equation, and then we can end up with V is equal to 10 volt. So that was the first question, that you need to calculate V. And then we can consider second loop. Second loop also consists of three components: 8 volt, 2 volt, and then 3Ix. Again we need to apply KVL, Kirchhoff voltage law, in this loop. So then again you can see current entering into the negative sign, so that is why here is negative. Current entering into positive, so that is positive. Current entering into positive, so that is positive 3Ix. So then if you rearrange this equation, you will end up with Ix is equals to minus 2 ampere. Then another example. So we again need to solve for the concept of Kirchhoff voltage law. So in this circuit, we need to obtain V1 through V3 in this circuits. So like if you see this circuits, a 24 voltage source, so this is unknown V1, so that is unknown V2, this is unknown V3, and then another source 10 volt, and then another source 12 volt. So for this solution, we will consider three different loops. The first loop is the outside loop. So you need to apply the Kirchhoff voltage law around this entire outside loop. So if you see that the current entering into the negative sign, so that is why minus 24. Current entering into the positive sign, so that is why positive V1. Current entering into the positive, so that is why positive 10. Current entering into positive, so that is why positive 12. So then from this equation you can see that the answer V1 is 2 volt. And then again you can apply Kirchhoff voltage law to another source like V2, 10 volt and 12 volt. So like this source V2, then 10 volt, and then 12 volt. So current entering into the positive sign, so V2 is positive. Current entering into the positive sign, so 10, and then current entering into the positive plus 12. And then from this equation you can end up with V is equals to minus 22 volt. And then the third loop, apply Kirchhoff voltage law to the third loop. So like V3 and 10 volt. So this one is the third loop. So current entering into the negative sign, so that is why minus V3. Current entering into the positive sign, so that is why 10. So rearranging will give you V3 is equals to 10 volts. So we'll end up with this problem. Another problem is that you need to determine unknown Vx and then the power absorbed by this 12 ohm resistor. So in order to calculate Vx, you need to first calculate the equivalent resistance of this whole portion. So let's start by by calculating the equivalent resistance of this whole portions. So like in this portion you can see this 8 ohm resistor is in parallel with the 12 ohm resistor. So similarly this 3 ohm resistor is in parallel with the 6 ohm resistor. So the answer of this parallel combination is 4.8 ohm. The answer of this parallel combination is 2 ohm. And then you can redraw that circuit again. The new circuit look like this, and 4 is in series with 2 and 1.2 is in series with 4.8. So it means that 1.2 plus 4.8 is 6 ohm, 4 plus 2 is again 6 ohm, and then the new circuit looks like this one. So again you see 6 ohm is in parallel with the 6 ohm, and then the answer is 3 ohm. So you can see that you have solved this whole portion, and then you find the R equivalent of this portion, that is 3 ohm. So you can again redraw that circuit. So the circuit looks like this one. So by using the current division rule, you can calculate the value of Vx here. So current division rule, so using the current division rule, Ix is equals to that 2 ohm resistor divided by 2 ohm plus 1 ohm plus 3 ohm, because this 1 ohm is in series with 3 ohm. So that is why you need to add them up, and then multiplied by 6 ampere. So that is the current is 2 ampere. So these two resistors are in series, so that is why the same current is flowing through these two resistors. So Vx is equals to Ix multiplied by 1 ohm, so that is 2 volt. So the other question is that we need to calculate the power absorbed by the 12 ohm resistor. So it means that we need to know either the current flowing through this resistor or the voltage across that resistor. So that is why. So if you see this circuit here, so it means that the total current flowing through this part is 2 ampere, but you can see the 6 ohm resistor is here, 6 ohm resistor is here, resistors are equal, so that is why 1 ampere current is flowing through this, 1 ampere current is flowing through that part. So that is why you can say Ix is 1 ampere is flowing through 1.2 ohm resistor. The voltage across 12 ohm resistor is 4.8 multiplied by 1, so that is why the answer is 4.8 volt. Now the formula for the power is V square divided by R. So V square is 4.8 square divided by 12, so the answer is 1.92 watt. So this is the current, and then this is the resistance here. If you see in this circuit, this one, because 4.8, the parallel combination of these two resistors. So if the parallel combination, so that is why voltage remains same. So that is why you can easily calculate by using this formula. Okay, another combination of circuit. Another example, you need to find R equivalent and I naught from this circuit. So this is I naught unknown and R equivalent is unknown. So from this circuit you can see that 80 and 20 ohm are parallel. So the answer of that parallel combination is 16 ohm. 12 ohm and 6 ohm is in parallel. The answer of that parallel combination is 4 ohm. And then you can redraw the circuit in this pattern like 4 ohm, 16 ohm and 60 ohm. And you can see that the 4 ohm is in series with the 16 ohm, and the answer is 20 ohm. Now that 20 ohm is in parallel with the 60 ohm, the answer is 15 ohm. Now the new circuit is 15 ohm, 15 ohm, and then 5 ohm. So you see 15 ohm is in parallel with 15 ohm. So that is why the answer is 7.5 ohm. And this 7.5 ohm is in series with 5 ohm. Then the answer is 12.5 ohm. So the R equivalent is 12.5 ohm. The second unknown parameter is I naught. So in order to calculate I naught, you can redraw that circuit like 40 volt with the R equivalent resistance, and then using the Ohm's law you can calculate I naught, which is equals to V divided by R equivalent. V is 40 volt, R equivalent is 12.5 ohm, and then I naught will be equals to 3.2 ampere. So another circuits, like in these circuits, R equivalent is given, so that is 50 ohm, but you need to calculate the unknown resistance in the given circuit. For the solution, you can take this part out, like these three 12 ohm resistors are parallel combinations, and the answer of those parallel combination is in series with this R unknown resistor. So the parallel combination will give you the answer 4 ohm, and then you can redraw that circuit in this pattern: 4 ohm or 10 ohm and then 60. So you can see this 4 ohm is in series with R and then 10 ohm. So and the you can say that this is X, and then that X is in parallel with this 60 ohm, and the answer of that is in series with 30 ohm. So you can say R equivalent is equal to 30 ohm plus this Y. And what is Y? X is in parallel with 60. And what is X? 10 ohm plus R plus 4. So like you can write this equation in this format: R equivalent, so that is 50, 30 ohm, and Y is 10 plus R plus 4 parallel with 60. So you can again solve this equation, and then you will end up with another equation like 74 plus R is equals to 42 plus 3R. Here I am dividing with 20 on both sides because to make it simple. So 20 cancel out with this 20, 20 will give you 3, and then you can solve for the R, which is equals to 16 ohm. And now another concept to calculate uh, the equivalent resistance if the combination doesn't look like series or parallel, like for a bridge type network. So you need to calculate RAB and I for these circuits. So you need to calculate the equivalent resistance and this I naught. So if you look these circuits, so you can say that this part might be the delta, or you can say this part might be the delta, or you can say this part might be Y combination. But what I suggest that okay, better to pick this part as a delta and then transform that delta to Y. So it is very easy that to take this part and read write like here, so delta combinations, and then inside that circuit draw Y combination. So in order to calculate this R1, so the answer of that R1 is the product of the adjacent components divided by sum of all the resistances. So R1 is equals to 6. Similarly for R2, product of this divided by sum of all. For R3, product of this one divided by all 3. So that is why you can calculate R2 10 ohm, R3 15 ohm, and then you can redraw the above circuit in this pattern, like you are inserting the delta portion by Y portion, and then it is very easy to calculate. Like here you can see these are series component, and then this 10 and 10 ohm are in series, 24 is in series with 6 ohm, and then their answer is in series with 15 ohm. And sorry, uh, then their answer will be parallel to each other. So like 30 is in parallel with 20, and then the answer is 12 ohm. So 12 ohm and 13 ohm and 15 ohm all are in series. Then you can say that the answer is 40 ohm or equivalent resistance. And now it is very easy to calculate I by using Ohm's law. So Ohm's law says that I is equals to V divided by R equivalent. So V is 100 volt and R equivalent is 40. So I is equals to 2.5 ampere. So let's solve another this type of circuits. Like we need to calculate the voltage across this resistor like 35 ohms. So in order to calculate this voltage, first we have to solve that portion. So if you look that portion, so this might be a possible combination that this looks like a Y a combination, but we can transform that Y into the delta network by using this network. So you can write Y and outside a delta. So for this R1, you can easily say that the combination of the product of these resistors divided by the adjacent resistor, that is 12. So the answer of that is 37.5 ohm. And if you want to calculate this R2, so the same answer is 450 divided by the adjacent component, which is 10 ohm. So the answer is 45. So in order to calculate that R3, the product of all the combinations, that is 450 divided by the adjacent component, that is 15 ohm. The answer is 30 ohm. So you can rewrite that circuit in this pattern and then insert this portion in this part, and then you can redraw that circuit in this way. So you can see this is parallel with that one, this is parallel with this one, this is parallel with this one. So 20 is parallel with 30, the answer is 12 ohm. 30 is parallel with 37.5, the answer is 16.667 ohm. 35 is parallel with 45, the answer is 19.688 ohm. And then all are in series, like 12 is in series with 16.667. Similarly 19.68, like here you can see 19.68 is in parallel with 28.667. Like you can redraw that circuit in this pattern, and then you can further solve that this series combination is in parallel with that one, and the answer of that is in series with this one. And now you can easily calculate the value of the equivalent resistance. So that one is 11.672 ohm. So here you can say that the 11.672 ohm. So by using voltage division rule to find V across that resistor, so you can use that value like V is equal to 11.672 divided by the sum of those components multiplied by 100. The answer is 42.18 volt. Or you can use alternate rule by using Ohm's law. You can calculate the current across that component. So because these are in series, so same current is flowing through these two components. So total voltage divided by total resistance, the current is 3.61 ampere. Then the voltage is equals to current multiplied by the resistance, and then the answer is still the same, 42.18 volt. So that's all for the concepts, and I think you understand all the numericals very well. But if you have any question, you can raise the comments. You can write your question in the comment box. Thank you.